Good morning and welcome to the 65th episode of the Sunday Science Demo Series. We are joining you today live from the Indian Institute of Science, Education and Research, IISER, which is located in Pune. And here you see some glimpses of the IISER Pune campus. IISER is basically a science education and a science research institute, which means that there is fundamental research happening here in the domains of physics, chemistry, mathematics, biology, earth and climate sciences, and humanities and social sciences. IISER Pune also offers courses for bachelor's and master's in science, integrated PhD in science, and PhD in science. And along with doing science education and science research, IISER is also very active in scientific outreach, which means that IISER hosts a large number of visitors, students and teachers who come here to get a glimpse of the IISER's work and to have a lot of fun learning and doing science. One of the main outreach activities at IISER Pune is done through the Nani Balan Science Activity Center, from where we are joining you today. And here we have a lot of interesting things like very nice science toys made from very easily available material, where students can get a hands-on flavor of science, try out things, and learn science and the fun of science, enjoy the fun of science in the process. A lot of teachers also join the Science Activity Center for workshops and programs, where they are very curious and excited to learn and get to know more about these hands-on activities so that they can try them out with their students. So every year, IISER Pune, the Science Activity Center at IISER Pune gets visits from a very large number of students and teachers who come here to see the fun science toys that are here. And you're all most welcome to come to IISER and see these for yourselves as well. And one of the activities of Science Activity Center is, of course, the Sunday live demo series, through which IISER connects with you from the medium of YouTube. And this is the 65th episode of this series. And today, we are going to talk about a very pertinent and important topic, which is the topic of climate change. And my name is Dr. Apurva Barve. I have been associated with IISER and I'm currently working with the Maharashtra State Faculty Development Academy. And today we are going to talk about the science of climate change. Climate change is a very complex topic which has a lot of facets of social as well as scientific relevance. And the first step to knowing about climate change is to understand it. And this is a topic, or this is a problem that all of us, and especially the students who are joining us, are going to face in their lifetimes. This is happening here today. And in fact, the World Health Organization in 2021 declared that climate change is the biggest health threat facing humanity today. And it is affecting all of the varied aspects related to health, from accessibility to very basic determinants of health like air, food, clean water, and so on. And it is causing a lot of additional deaths. Almost 2.5 lakh additional deaths are expected to be caused just by climate change between 2030 and 2050. There is, of course, a lot of financial damage that is caused to the society, to the economy of the world because of climate change. And like most of the problems, countries and societies which are still in the stages of development, which do not have access to a lot of resources, are the worst hit. So this is a grave and multifaceted problem. And this is something that we are all going to already starting to face the effects of. So what do we do? This is something that we have to accept that it is happening. And the first step to addressing any problem is to understand it well. And this is what we are going to try and do in this session today. We are going to try and understand the scientific aspects, the science behind this complex problem. So before we move on to discussing more about climate change, let's get the basics clear. Let us first talk about the difference between weather and climate. What is the difference between weather and climate? Weather is a short-term status of the atmosphere around us. For example, weather talks about, both weather and climate talk about things like atmospheric pressure, temperature, wind, rain or snow or cloudiness, and so on. But weather talks about this on a short-term, day-to-day kind of basis, whereas climate talks about long-term trends in the weather, long-term average conditions of the weather at a given location, at a given point on the globe. And of course, you can imagine this with an analogy that the weather tells you what to wear today, whether it is rainy and you need to carry an umbrella, or whether it's cold, so you need to wear a sweater. Whereas the climate will tell you what kind of clothes you have in your wardrobe. For example, if you live in a very cold region like Kashmir or somewhere in Europe, you are more likely to have very thick sweaters and warm woolen clothes, whereas if you live in a place like Chennai, which is hot and humid, you are less likely to have those kinds of clothes, whereas more likely to have light cotton clothes and things which you can wear in the rainy weather, and so on. So climate tells you the longer term average status of certain atmospheric conditions, whereas weather talks about the current, present one. It's almost like saying, weather talks about how your mood is today, whether I'm happy this morning or I'm irritated or angry or so on, whereas the climate talks about how my overall personality is. In general, am I a happy person? Am I a grumpy person? And so on. So that is about weather and climate. So one has to remember that when we talk about climate change, you can't say, oh, but it's so cold today, how can there be global warming and climate change? Because we are not talking about the temperature and the conditions of one day, but we are talking about something which is happening over a long period of time. So now that we've seen the difference between climate and weather, let us look at what climate change is. Climate change, according to a definition given by the United Nations, is long-term shifts in the temperature and weather patterns. So climate itself is something that we look at averaged over a long period, and climate change is something which looks at even larger time frames of how these average climate patterns have been changing over decades or maybe a few hundred years, and so on and so forth. So let us hear a little bit from you now about what you think about climate change. What are some of the terms that you associate with climate change? What are the causes? What are some of the causes of climate change? It would be great if you write your responses in the chat box so that we can try and see if some of those terms are going to come up in our discussions today. And let's see what we come up with. This is a term that we've been hearing on the news, in the newspapers, when people are talking casually to each other. It keeps coming up. So I'm sure all of you have heard this term somewhere or the other and have images and impressions about climate change and what causes it and so on. So we are starting to get a few responses. Dwij says it's global warming. Yes, global warming is one important element of climate change, though it is not the only aspect related to climate change, but global warming, certainly. Pollution, yes and no. Pollution and global warming are very intricately related in some ways that we will soon see, but there are other aspects to climate change as well. Greenhouse gas emissions, greenhouse gases. We are getting very interesting answers on the chat here. Deforestation, absolutely. This is one of the major factors contributing to climate change. Great. Greenhouse gases, melting of glaciers, global warming, pollution, and so on and so forth. So yes, global warming is one of the main aspects that you hear about, and greenhouse gases and greenhouse effect is one of the many important things that one thinks about when you think of climate change. So greenhouse, a glass house in which usually plants are grown, particularly in colder regions and colder climates where it's not warm enough outside. And what does a greenhouse do? Usually greenhouse keeps the inside of the greenhouse warmer than the outside. And when you say that, oh, there is greenhouse effect and there's the that is causing global warming, one imagines that the earth itself is inside a greenhouse, and there is something that is keeping the inside of the earth warmer than the outside. Is this a notion or sense that you have got when you hear the words greenhouse effect? Let us first see an experiment to actually verify this principle. Let's look at an activity to demonstrate or make a small model of the greenhouse, right, which is something that you can do right in your homes, and let's see how that works. For this activity, we will require a thermometer, or rather 2 thermometers, a glass container, and some clay or something which you can use to seal the glass container. Here you go. You don't have to use electronic thermometers. You can also work with regular thermometers, analog thermometers. And what you do is to, we'll pause that for a minute. Yes. What you would need to do is to place the 2 thermometers in a sunny place, or if it's not very sunny outside, you can use a very strong lamp that gives off a lot of heat out in the sun. And you have one thermometer which is directly under the sun and the other which is sealed inside the container. So this container is our model of a greenhouse. And once you set this up and seal the container, here a foam sheet has been used to seal the container to make sure the outside air does not go in, but you can use some Play-Doh or modeling clay to seal the container. And you start measuring the temperatures after keeping the setup outside. And you have a control, which is the thermometer kept outside, and you are measuring also the temperature inside the container. You will see that as time goes on, the temperature inside the container seems to be rising faster than the temperature outside of the container. There is something about the container that is making the inside warmer than the outside, just like a greenhouse or a glass house. And of course, you can do this with, if you don't have a thermometer, you can even try this with a small piece of cold butter, which you can, one piece of butter outside and one piece of butter inside, and you can see which one melts, or a small piece of chocolate, and you can see which one melts faster. You may not get a specific reading of the temperature with butter or with chocolate, but you will still see which one melts faster. And you will see that something which is inside the thermometer or the butter or the chocolate rises in temperature faster than the inside. You can see here that after about 14 minutes or so, the difference from the beginning and at the end of 14 minutes was about 13 degrees outside, where the thermometer was directly kept in the sun, whereas inside it was almost 20 degrees, which means that the temperature inside the container was significantly higher than the thermometer kept just outside in the sun. So this is actually what happens in the greenhouse effect. This is what happens inside the greenhouse as well. And this is an analogy which is used to understand the greenhouse effect on the earth as well. So what is the greenhouse of the earth? It is actually something in the atmosphere. Just like the glass container was keeping the atmosphere inside the container warmer, there is something in the earth's covering, the layer of atmosphere around the earth, that is keeping the earth warmer than outside. And how does this work? Sun is basically the source of most of the energy, almost all of the energy that the earth receives. And much of this energy from the sun crosses the atmosphere and comes to the earth. Some of it also gets back to the space because it is reflected. And the earth, like any other object, absorbs this energy and emits much of the energy in the form of infrared radiation. Infrared radiation is a form of heat, a form of energy which we sense as heat. So when the earth emits the infrared radiation, it crosses the atmosphere and much of it goes out into the space. However, there are some things in the atmosphere, some gases or some molecules in the atmosphere, which trap this energy, trap this infrared radiation, and scatter it again in all directions, including back towards the Earth's surface. Because not all of the energy emitted by the Earth is now able to cross the atmosphere and go out into the space, and some of it is returning back to the Earth's surface, this leads to a rise in the temperature of the Earth. This is what the greenhouse effect is. And the experiment that we did with our container, keeping the inside warmer out in the sun than outside, was an analogy. Actually, in terms of actual physics, the effect that you see here in the glass container is a combination of the actual greenhouse effect caused by the glass and an effect of containment, which means that the air and the energy is kept inside the glass. But it is a very useful analogy to understand what happens and how greenhouse effect works at the level of the Earth. You just should remember that this is an analogy which was actually, in fact, used also by Arrhenius, one of the main discoverers of the greenhouse effect, back in 1896. So this is how the greenhouse effect works, but one must remember that it is not the entire atmosphere that is absorbing and re-emitting this infrared radiation. The atmosphere, as we know, is made up of many gases, the most prominent of which is, any guesses? Yes, nitrogen. Oxygen, for example, makes up almost 18 to 20% of it. But none of these gases act as greenhouse gases, or they don't have this property of trapping of the heat, infrared radiation emitted by the Earth and sending it back to the Earth. There are only a certain select gases which have this property, and these gases are called as the greenhouse gases. So it is only these gases in the Earth's atmosphere that trap the infrared radiation emitted by the Earth and send it back to the surface, causing a rise in the temperature. And what are some of the examples of greenhouse gases? The most prominent or the most well-known one is, of course, carbon dioxide. Then there is also methane. There is nitrous oxide. Ozone is also a greenhouse gas. Some man-made gases, the chlorofluorocarbons, for example, which are used in refrigerators or other cooling devices, are very, very strong and powerful greenhouse gases. Sulfur dioxide, nitrous oxide, these are some of the other examples of greenhouse gases. And in fact, one must remember that water vapor, our very own water vapor, which plays such an important role in the hydrological cycle of the Earth, is also a greenhouse gas. So, one thing to remember about greenhouse gases, greenhouse effect, is that it is a natural effect. It is not that the entire effect is being created by human activities. In fact, if we did not have an atmosphere containing these greenhouse gases, the average temperature of the Earth would be minus 18 degrees. It is that important, the greenhouse effect is that important for keeping our temperature a very cool, an average temperature of 15 degrees Celsius, which makes it possible for life as we know on Earth. If we did not have an atmosphere at all, and if all of the infrared radiation was going out and away from the Earth into the space, the surface temperature would be very, very cold indeed, and Earth would not have this kind of life and this kind of biodiversity that we see today. Perhaps there would be a different kind of life and living organisms living on the Earth, but you and I probably would not be here. But the greenhouse gases keep the Earth's atmosphere warmer and maintained the temperature till about a few hundred years ago to an average of 15 degrees Celsius, which is an average, mind you, of very cold temperatures on the pole and very warm temperatures near the tropics, near the equator. And the average of all that is about 15 degrees Celsius, though we may not experience 15 degrees in our day-to-day lives, because here living in India, we are in a tropical region. But the average temperature of the globe is 15 degrees, and that is thanks in part to the greenhouse effect. So then if the greenhouse effect is normal and natural, and in fact it is what makes life possible on Earth, what is the problem? The problem is that human activities are enhancing the greenhouse effect. They are making this effect stronger. Because we are increasing the proportion of these greenhouse gases, which have the property of absorbing and re-emitting infrared radiation into the atmosphere, we are leading to a stronger greenhouse effect. So the energy budget of the Earth is being disrupted due to addition of excessive greenhouse gases in the Earth's atmosphere. If there was a stable balance between the sun's energy, the energy received from the sun by the Earth, and the outgoing energy, energy emitted by the Earth in the form of infrared radiation, now there is an imbalance because of a lot of excessive greenhouse gases in the Earth's atmosphere. And these come from deforestation, as one of our friends mentioned, come primarily from burning of fossil fuels, burning of trapped carbon, which was sitting deep inside the Earth. We are now removing that in the form of coal, in the form of oil, in the form of petrol, and so on. And we are burning it and releasing that in the form of carbon dioxide into the Earth, which is a greenhouse gas. More fossil fuel burning, more greenhouse gases, more trapping of heat, right? And it's not just CO2, though that is the primary one responsible for it. There are other greenhouse gases, as we have just seen before. And in fact, they have a much stronger greenhouse effect than CO2. CO2, if the amount of heating or warming caused by 1 ton of CO2 in the atmosphere is considered as 1 unit, the amount of heat trapping and warming caused by methane is 25 times of that. And that caused by nitrous oxide, another greenhouse gas, is 300 times of carbon dioxide. And fluorinated gases are in fact much more powerful, more than thousands of times powerful than CO2. So you see, it's not just CO2 or carbon dioxide that we need to worry about, but we need to also make sure that the proportions of all of these other greenhouse gases are also maintained lower and the emissions are decreased. And yes, although all of the other gases like nitrous oxide, methane have a very strong effect, strong potential to increase the Earth's temperature, right now the most prominent warming that we are seeing is due to carbon dioxide, because of its sheer large proportion. We are releasing carbon dioxide into the Earth's atmosphere at such a big rate that it is causing a huge amount of global warming. Most of the warming that is caused on the Earth is caused by carbon dioxide. Here you can see broadly the proportion of various gases that are causing various amounts of global warming. And of course, this can change depending on how we change the emissions of these gases and the proportion of emission of these gases over time. The proportion of gases contributing to greenhouse effect and contributing to current global warming will go on decreasing. You also see in the graphic some of the sectors like transport or energy or industry or even agriculture, because agriculture releases a lot of nitrous oxide as well as methane, which are both very strong greenhouse gases. And you can see the proportions of those in global warming, in contributing to global warming. So why are we really so worried about some more CO2 in the atmosphere or some more methane in the atmosphere? For that, we should look at how the Earth has been historically. And this is a graph that shows us global temperatures, the temperature of the Earth, and carbon dioxide concentrations and sea levels over 400,000 years. Scientists have deciphered or calculated the temperatures and CO2 concentrations of the Earth over a very large period of time. And how do they do that? They do that by digging in to extract the ice cores which are located at the poles. When snow falls, some air is trapped along with the falling snow, and as more and more snow falls, this snow and the air trapped in it gets buried deeper and deeper and deeper. And when you drill a hole in the snow or in the packed ice at the poles, at North and the South Pole, and you extract that core, you find some bubbles of air which were trapped all that time ago when the snow was first falling. And when you analyze those bubbles of air, you can figure out how much the global temperature and how much CO2 was there in the air at that time. And by doing these ice core analysis, scientists have found or plotted a graph of the temperature, concentration of CO2 and sea levels of almost more than 400,000 years. And what you can see here is that the global temperatures and CO2 concentrations are one, very closely linked to each other. When there is a rise in CO2 concentration, there is a rise in global temperature, and also a rise in the sea levels, which you can very clearly see from these peaks which follow each other and the troughs which follow each other. Lower global temperature, lower CO2 concentrations, lower global temperatures, lower sea levels. And you can also see that in the past few years, in the past few decades, the temperatures and the CO2 concentrations have begun to rise. In fact, the carbon dioxide concentrations, which have been between this range, they have been oscillating in a certain range, and now we are starting to go out of that range. We are seeing carbon dioxide concentrations in the atmosphere which have not been seen in the past 400,000 years. So this is a very, very unprecedented event which has not been seen on the Earth for a very, very long time. And let us see actually how temperatures have changed from approximately 1880, when they started to record these temperatures, to now. Here is a video which shows you the average temperature from 1880 to now, taken every 5 years. So 1880 to 85, then 81 to 86, and so on. The cooler temperatures are depicted in cooler colors of blue, whereas the warmer temperatures are depicted in warmer colors of yellow, orange, and increasingly even red. So you will see that over the years, the temperatures have been increasing. And let us look at the video one more time. And now this time, when we see the video, you have already seen how the Earth has grown from being cooler and bluer to more and more warm. Now, I would also like you to notice where this global warming or where these warm temperatures are actually happening more. And you will notice that not all parts of the Earth are warming equally. You will notice that in certain parts of the Earth, particularly the North and the South poles, there is much more temperature rise than in the other parts of the Earth. So this is data up to 1822 captured by NASA, and you will find the link to this video in the description box in case you want to take a look at it later. So this is how the temperatures have been rising, and models, scientific models, computational models have predicted that if we go on adding more and more CO2, we are already at around over 400 parts per million. So that is how CO2 is usually measured. How many parts per million parts of air? How many parts of CO2, carbon dioxide, are there per million parts of air? And right now we are at around 410 parts per million, which is way beyond this historical range of between 0 to 300 parts per million of carbon dioxide over the last 400,000 years. We are already have crossed that and gone quite ahead to almost 410 parts per million. And if we go on doing that, if we go on adding more and more carbon dioxide, one possible scenario is that we might end up with 750 parts per million by 2100, which is actually not too far from right now, which is actually will be in the lifetime of some of the people who are just born in the last few years. It will be in their lifetime that we might see a temperature rise of almost 4 degrees, or a CO2 concentration which has never really been seen before. So the temperature is rising through the effect of human activities putting more and more greenhouse gases. And what does that temperature rise mean? What is the effect of the rise in surface temperature of the Earth? Write your responses in the chat box, and I'm going to give you a few minutes. Yes, it is indeed very, very dangerous, but we must see what we can do about it. What do you think are the effects of the rise in Earth's surface temperature, which has risen, by the way, by about 1.1 degrees on average over the entire Earth in the last few years, in the last few decades, in comparison to the average of pre-industrial era, where there was not so much industrial activity and there was not so much carbon dioxide and other gases going into the atmosphere. Compared to that level, we are at 1.1 degrees higher temperature on average all over the Earth. Okay, great. Global warming, melting of glaciers, Earth core, well, not quite. We are not right now affecting the Earth core from what I know, but water shortage, yes, coral bleaching, glacier melting, increase in sea levels, famines, human interference, absolutely. So you are all very aware of what this small rise in temperature can do to us, can do to our nature, can do to our lives, and can do to our Earth's health, basically. So, as some of you were saying, it has melting or rising temperatures have a lot of effects, and one of the primary things that it affects is the cryosphere. Cryosphere is basically the icy part of the planet. We always call Earth as the water planet, right? 75% of or 70 odd percent of the Earth is water. But we also must remember that a big part of this water is in the form of ice. And this is a view of the Earth that we don't often see usually in maps, because we never look at the Earth from the top or the bottom. Whereas this photo is showing you how the Earth looks like right from the top or from the bottom. And you see the Arctic on the top and the Antarctic at the bottom. And they are indeed quite white, because the temperatures at the poles are very cold, and much of the water there is in the form of ice. This, in fact, is what an Arctic or an Antarctic landscape would look like. And you will notice, the first thing that you will notice is that it is extremely white. It is very, very white indeed. And this whiteness is changing. It is reducing. For example, this is a satellite picture near Greenland taken in 1979, and the same spot photographed or imaged in 2007. And you will notice that there is a substantial decrease in the white area, right? There was much more white portions in 1979, which is now all melted, and it's part of the sea in 2007 already, and now it's even worse. But why am I talking about the color? I keep saying it was white before, and the Arctic landscape is very white. And does the Earth's color have any effect on its temperature? Indeed, it does. And this is because of what is called the albedo effect. Let us now see how the albedo effect works, and let us now see a small activity to demonstrate the albedo effect. So here is a demonstration of the albedo effect. For this, you will need 2 thermometers, electronic or otherwise, and black and white containers. You can also do this with a black and white fabric. And as before, you keep 2 thermometers in the black and white fabric or inside black and white liquid containing containers, and put it out in the sun. And you keep observing it, keep seeing the temperatures in both of the containers, black and white, over a period of time. And you will see, in fact, as you are already starting to see, that the black warms up much faster than the white. This is something that you experience inside in the inside of a black car which is parked in the sun, for example, or a black cloth that is being put out to dry, or this is the reason why our parents and grandparents always tell us not to wear black clothing in the summer when we are going out and so on. So if we can look at the video once again, and look at the very end of the video where we see the graph of the temperatures, we will see that in fact there is a substantial difference from minute 0 to minute 30. After half an hour out in the sun, the temperature of the white liquid or the white substance increased by about 7.5 degrees, whereas the black substance increased by almost 11 degrees. So that is the kind of effect that color has on the temperature. And this is exactly actually what is happening at the level of the Earth. Albedo, which is the ability of a surface to reflect sunlight, changes between colors. The light surfaces have high albedo, which means that they reflect the sunlight more, whereas dark surfaces have a lower albedo, which means that they absorb the light and hence the energy and the heat more. So this is what happens when the sunlight hits a surface which has snow, whereas versus sunlight hitting, say, the ground, which is dark brown in color, or water, which looks bluish in color. And this is exactly what is happening at the level of the earth as well. More albedo, and in fact, this is caused the melting of ice a lot. The global warming has caused the melting of ice a lot. And because of this reflection, this leads to even more increased temperature. This is something which is called the positive feedback loop. Due to global warming, due to additional greenhouse effects in the atmosphere, the temperature of the earth rises, which means more ice melts. As more ice melts, more water is exposed or more ground is exposed, which absorbs more heat, hence leading to even more temperature rise, which causes even more ice to melt, and so on and so forth. So this effect keeps making itself stronger and stronger because of albedo and because of the difference in the capacity to reflect sunlight between white surfaces versus dark surfaces, light surfaces versus dark surfaces. And hence this creates a positive feedback loop leading to even more temperature rise and even more global warming. So this is one important impact of the melting of ice. Are there other impacts that you can think of? Are there other impacts of melting of ice? Somebody already mentioned this in their previous answers. What are the impacts of warming of the earth? And it is indeed sea level rise, right? So one is the melting of ice causing an albedo effect to reduce, the albedo effects to reduce, and hence causes more temperature rise. On the other hand, melting of ice is also causing sea level rise. But we must remember that ice is present, or snow and ice are present on the earth in two different forms. One is ice on land, which is called the continental ice because it's on the continents. And this is in the form of glaciers, which snow, masses of snow in the mountains or valleys accumulating and moving down, or icebergs on the land. And of course, the sea ice, which is in ice in the oceans, in the seas itself. And of course, because of rise in temperature, both of the continental ice as well as the sea ice are melting. And melting of which ice do you think is causing the rise in sea levels that we are seeing? So let us do a small poll to check this. And the sea level rise is caused by melting of what? Ice on land, which is continental ice, or is it the melting of sea ice, which is causing the rise in sea levels, or is it both, or is it none? And let's see what the poll is telling us. I'm going to give you a minute to answer the poll. Okay. We have some responses saying it is the sea ice which causes the melting, rise in the sea levels. Okay, more and more people saying it is the sea ice, and fewer people thinking that it is the land ice. And let us really see which is the one which is causing it. And for that, we have another interesting activity. Let us look at the activity. And for this, we need two containers, bigger containers for water, one continent, something to represent a continent, and of course, a lot of ice and water. So in one container, we have the sea, which is just water, and in one container, we have the sea surrounding land, which is the continent. And then we put some ice in both the sea as well as the land. And this is what will represent our sea ice and the continental ice. And of course, we mark the levels. We mark the level of water because the sea level rise is what we want to measure. We mark the level of water before before the ice starts melting on the continents. Because the sea ice already exists in ice, we mark the level of the water after we put in the ice inside the sea, and then we mark the water level. So now we have sea ice and continental ice, and we are waiting for it to melt, just like it's happening on the earth due to global warming. So you see that the ice in water has already melted, and it melts much faster, in fact, because of the ability of the ocean to move energy around. And now the continental ice is also melting. And in fact, what you see here, that contrary to what most of our friends expected in the pole, the melting of the sea ice has not really changed the level of the ocean. Whereas the melting of continental ice has led to the increase in the level of the ocean. So you see that it is, in fact, you can see here as well in the diagram, that the melting of sea ice does not lead to any change in the level of water, that is the level of sea, whereas the melting of continental ice, which melts, which was the ice which was, or water, mass of water which was in the form of ice on the land, on the continents, melts and gets added into the volume of sea, leading to an increase in sea level. And what really is the science behind this? Why does the melting of sea ice not lead to an increase in sea level? And the answer there is because of the properties of water versus ice. As we know, ice has lower density but larger volume of water. For example, if 1 liter of water has a volume of 1 liter, of course, but if you were to convert that 1 liter of water into ice, if you were to freeze it, that volume would be larger than the volume of 1 liter of liquid water. And the ice which is already inside the sea ice is already occupying some space, with only a little part of the ice above the surface. So most of the ice is already occupying some volume in the sea, and a little bit is outside. In fact, it is 10% of the volume of ice which is above the sea level. And when this entire ice melts, both the one inside the sea and one above the sea, when the entire ice melts, the volume of water that it now occupies in the molten state is exactly equal to the volume displaced by the frozen ice, right? So this means that this space which the ice was initially occupying is now getting filled up with the melting of the entire ice chunk above and below the water. This is why you do not see a rise in the sea level after the melting of sea ice, whereas in case of continental ice, this ice was never a part of the sea. So the volume of water was outside of the sea, and now it is melting and going inside the sea, which is why it is causing a rise in the ice levels. Of course, we do need to remember that even though the melting of sea ice is not causing a rise in the sea level, it is still harmful because it is decreasing the albedo effect and leading to an even higher rise in the temperatures. But when it comes to sea level rise, although it is only caused by the melting of continental ice, it is not the only cause of sea level rise. Just the melting of continental ice is not enough to explain the levels of sea level rise that we are now seeing. There is another cause, and the answer to that lies in looking at where global warming is going. The 1.1 degree rise in the Earth's temperature that we are seeing, most of the extra energy trapped, most of the extra heat trapped by these additional greenhouse gases that we are putting in the atmosphere is going into the ocean. More than 90% of the energy is in fact going into the ocean. And hence, what do you think that will lead to? What happens when an object is warmed? In this case, it is the ocean which is our object. And what happens when an object absorbs heat? Let us see what happens. We have a small activity to do that. And we have some seawater, which has been painted blue with some ink. Inside, which is usually seawater is cool, right? So it is cool seawater which is inside a closed bottle completely filled, and it has a straw inside. And let us mark the level of the sea before we begin the experiment. It is a sealed bottle which has a straw inside it, and the bottle is fully filled with water. Now this bottle containing cool water we are keeping inside a jar containing warm water. And this is what is happening because the atmosphere is warming and the sea is absorbing this heat, just like our cold ice bottle is absorbing the heat here from the warm water in the jar around it. And you can see that the level of water, or the column of water in the straw is rising very, very significantly and very, very clearly. Because, again, the basic fundamental physics principle that when any object absorbs heat, it expands. And this is exactly what is happening to our oceans, because most of the global warming, most of the extra energy that is being absorbed by the greenhouse gases is going into the ocean. The ocean is expanding. It is occupying the same amount of water, is occupying a larger volume, and where will it go? It will come out, right? It will cause a rise in the level of the sea because it will come out from the space that it was initially occupying. So you can see from here that since 1960, the ocean heat content, the heat content of the ocean has been steadily increasing, and it's not showing no signs of stopping. As we have seen, upon heating, objects expand and occupy a larger space, and hence this is a major contributor to sea level rise. So melting of the continental ice, which is actually adding more volume from ice which was on the land, now is going into the sea in the form of water, plus the expansion of the ocean because of the thermal expansion, because it now occupies larger volume. Both of these together are causing a rise in the sea levels at the rate of about 2 to 3 millimeters now, almost close to 3 millimeters per year now. 3 millimeters probably sounds to you as a very, very small amount, but imagine that this is happening all over the world at a huge, huge scale. And we will soon see in the next slide what problems this can cause. But for now, what we can see here is that the total sea level rise, out of the total sea level rise, a big part of it comes because of thermal expansion, and then because of melting of land ice which is on the land and getting added to the sea. And what impacts does sea level rise have? When those of you who are staying in coastal areas will know that there is a level at which the sea is at low tide, and there is a level at which the sea is at high tide. And there is something which is called storm surge, which means that when there is a very high rainfall and winds and storms, the level of the sea rises even beyond that of the high tide, and it occupies some inland area and comes into the plains, which comes into the coastal parts of our cities and towns, and in general the coast, right? So, and that area which is occupied by the flooding waters during storms is called the floodplain. And earlier, if this was the level of high tide, and this was the level to which it would come to during the storms. Now, because of sea level rise, because the sea is now occupying more and more space, the high tide level is higher, and the floodplains, the amount of land occupied during floods and storms is going to become even higher. It's going to be even more. And this is the prediction, for example, for 2050. And by 2100, with even more sea level rise and even more melting of glaciers and higher temperatures and so on, it could go on to actually start getting into areas which are being inhabited by cities and towns and people and so on. So this is one of the major aspects of sea level rise. And in fact, this is not very far away. We are already starting to see some effects in our next door neighbor in Bangladesh. This is a map of Bangladesh, which is a land which is a country with a lot of low-lying land. In fact, it's not just Bangladesh, it's also parts of West Bengal, the Sundarbans, which as you know are the deltas formed where the Ganges meets the sea, and it's a very low-lying area with a lot of islands and marshes and so on. It is very, very densely populated as well. Both West Bengal, the Sundarban regions of West Bengal, as well as Bangladesh, the coastal regions of Bangladesh are very low-lying and very highly populated. And this is what sea level rise of 1 meter which is predicted to happen by 2100 if we don't control the amount of greenhouse gas emissions. A substantial portion of the land of Bangladesh could actually be underwater. There are already very strong floods, and in areas where people are living, like roads or people's houses and so on. And it is, in fact, developing countries who do not have as many resources and do not have enough infrastructure who are going to suffer the most from this. There are, in addition to developing countries with low-lying areas, there are small island nation states, for example, Maldives or Seychelles, or our own Lakshadweep Islands, which are very much at the sea level and can get completely inundated even by small amounts of levels of rise in the sea. So it is not just something which you see in a picture or in a diagram or in theory, but it's something that we are actually seeing happening in practice. So that's about sea level rise. There is one more big issue that the ocean is suffering because of climate change, and that is to do with the not so great chemistry of carbon dioxide and the sea. You see, carbon dioxide, when it comes in contact with water, it reacts with water and leads to the formation of carbonic acid. This carbonic acid, H2CO3, gets dissociated into hydrogen ions and carbon dioxide and carbonate ions. Sorry. So carbon dioxide plus water gives a carbonic acid, which is H2CO3, dissociating into hydrogen ions and carbonate ions. Now, more the amount of carbon dioxide in the atmosphere because of our activities, the more of it is going into the ocean, which means the more carbonic acid forming in the ocean and higher number of H plus ions which are floating around in the ocean. And what effect can this have? This effect of seawater becoming a little more acidic, because you know that higher H plus ions means a lower pH, which means more acidic pH, right? And what does the effect of this acidification on life in the sea? Let us look at a small activity to see what happens when the ocean water becomes acidic. This is a sort of exaggerated activity. We are going to try and put some seashells in very, very acidic solution like vinegar. So you need a glass of water, a glass of vinegar, which has a very low pH, and we are going to try and put some shells inside these two solutions. So some water, some vinegar, and some shells is what you will need. Seashells or shells of mollusks like snails and so on, because they are all made of calcium carbonate. Please keep in mind that this is not something that is happening right now in the sea, because vinegar is very, very much more acidic than the actual seawater. But we can get a sense of what happens or what can happen when the seawater starts to become more and more acidic. When you look at it up close, you can see that the shells in water are quite happy, and as they are, whereas those in vinegar, they are starting to release bubbles, and these are in fact bubbles of carbon dioxide being released by the interaction between calcium carbonate in the shells and the vinegar. And if you keep this in if you keep the shells in vinegar for a longer time, they will eventually degrade. They will eventually turn into almost powder if you keep them for a very long time. So this is the kind of effect that acidification of the ocean can have on the life in the sea. Again, remember that the activity that we saw was a very exaggerated version, just to give us an idea of the kind of chemical reaction that goes on between acidic environment and shells or calcium carbonate bearing animals, right? So what happens actually, what is happening right now in the ocean is that, as we saw, carbonic acid is being formed because more and more carbon dioxide is entering the ocean. It is dissociated to H plus and carbonate. And this carbonate, which is a very, very important molecule for forming the shells of animals or exoskeletons of animals like corals, for example, they are made of calcium carbonate. And this carbonate is important for forming those shells. But calcium carbonate will join with hydrogen ions floating around, and because the ocean is now becoming more acidic, there are more hydrogen ions floating around, and this calcium carbonate likes to go with these free hydrogen ions to form bicarbonate rather than going with calcium and forming calcium carbonate. So the chemical reaction tends to proceed towards the formation of bicarbonate rather than formation of calcium carbonate, which is required. This chemical reaction of calcium and carbonate coming together to form calcium carbonate is required for the formation of shells and corals of animals. And this is hampered by having more and more free floating hydrogen ions, which means that more and more acidic oceans. And this affects or impedes the impact or the formation and growth of animals which have calcium carbonate in their shells. And what are the animals that have calcium carbonate in their cells? A lot of animals. And before we can actually see a quick video of effect of acidification on a live animal. We saw an exaggerated version where we saw shells being put into vinegar. Now let us see how acidification or exposure to very high carbon dioxide, again exaggerated exposure to high carbon dioxide, affects a live animal. And you can see a pteropod, a marine organism, which was happily swimming in regular water. When it is exposed to high levels of carbon dioxide, the shell has become brittle and it has holes, and it has become very, very sluggish. It is not able to swim around as effectively. And though in this experiment there was a very high quantity of CO2 that it was exposed to, this is something of the nature of what is happening now in our seas with more and more carbon dioxide added, right? So ocean acidification affects all marine organisms, and that includes everything from echinoderms like sea, starfishes, which belong to the category of animals called echinoderms, then mollusks which have cells, which includes bivalves and so on, or arthropods like crabs or shrimps which have shells made of calcium carbonate, and of course corals. And why are corals so important? Their exoskeleton is also made of calcium carbonate, and corals which in warm shallow waters near the shores or near where there is land, in shallow waters these corals form huge colonies which are called coral reefs. And though they occupy only less than 1% of the entire marine environment, they are home to almost 1/4 of all of marine life. They are extremely rich ecosystems which harbor, of course there are thousands of corals living, or millions of corals living in a coral reef, plus they harbor a lot of other animals, fishes, small and large, anemones, and different kinds of animals. And corals being affected or their growth being affected means that all of this 25% of marine life which lives in the coral reefs is also affected. You see here a map of the location of coral reefs in different parts of the world. You can see that even in India we have coral reefs near Lakshadweep and on some of the coastal regions of India. And corals get affected by global warming or climate change in two different ways. One is that acidification, like we have just seen, it sort of prevents their exoskeleton from forming, which means weak skeletons and slow growth, and warming of the ocean, which we have also seen that the ocean is absorbing a lot of energy and becoming warm, and this causes coral bleaching, which means that the algae which live inside the coral are now moving out of the corals, which can lead to the death of the coral, because they are symbiotic animals which live with the coral. Again, for the future, we must remember that the pH is a log scale, which even a small difference of a few units can lead to a drop in the pH, substantial drop in the pH, and is going to affect a lot of animals. So we have basically seen the effects of the scientific basis of the effects of climate change on various aspects. We are right now at very, very high, the latest report of the Intergovernmental Panel on Climate Change, which is IPCC, which is the most authentic and the highest, the most respected body, which is giving information to us about climate change based on scientific studies. They have said in their latest report, which came out last year, that we are at CO2 concentrations and sea level rises, which are unprecedented, seen in CO2 levels highest in the last 2 million years, almost sea level rise and Arctic sea melting and glacier sea melting, which has not been seen in thousands of years. One must remember that Earth is a climate system. We cannot separate the melting of ice from what is happening to other things and other aspects of Earth. Most of all, we have the hydrological cycle and the weather patterns, weather systems, the convection currents of water as well as air, which take the effects of things happening in one part of the Earth all over the place. Right? It is a system which affects each other. The snow affects the ocean, ocean affects the rainfall, rainfall affects all kinds of things, causing drought on one hand to floods in some regions and very, very high temperatures and so on. So it is all a system, and maybe we can do another set of talks and activities to see how this Earth is a system and can have one change in one part of it can affect the another. But for now, you can see that global warming or climate change caused through warming of the Earth is going to have an effect on very, very diverse aspects of the Earth, from increase in the ocean temperature to sea levels to melting of ice, excessive rainfall in some regions to excessive droughts, higher incidences of forest fires. We have seen there is a lot of data consistently now that extreme events of weather, for example, storms and floods and forest fires or droughts or heat waves, they are increasing in frequency as well as in intensity due to climate change. Because of this 1 degree temperature increase in the average temperature of the Earth, there are a lot of different kinds of events happening. A lot of biodiversity is getting affected. And in fact, you see the various domains in which climate change is having an impact, from droughts and floods and storms, which cause displacement of human beings, right? People who living in areas which are experiencing constant and frequent storms tend to get displaced. They have to leave their homes and their livelihoods and go away somewhere, which leads to poverty and which leads to migration and a lot of other problems. Because food security is being affected, crops are being affected, it leads to undernourishment and malnourishment, especially in populations, again, which have access to less resources. We have made a lot of, over the years, with improvements in science and agriculture, we have made a lot of gains in food security. Now we have a little more food security for the global population than we had before, but due to climate change, that is coming under threat. So basically, we see that the entire Earth system is getting affected by climate change. And where is the future going? There are two possible scenarios. We can either take actions to reduce our greenhouse emissions and reduce the impacts of climate change, or if we don't do anything, we are actually headed towards very, very high emissions of methane and nitrous oxide and carbon dioxide and so on. And the IPCC, the Intergovernmental Panel on Climate Change, has made different kinds of predictions of what can happen if there are minimum emissions. We have already put so many more greenhouse gases into the atmosphere that we are still, even if we reduce our emissions now, we are still going to face some effects of climate change for the next few years. These are predictions up to 2100, the year 2100. And if we control the emissions, we are still going to face some effects, but they will be milder. On the other hand, if we take a scenario of growing, if we keep increasing the rate of greenhouse gas emissions without really doing anything about it, we are headed indeed for a very, very warm Earth and a very, very wet Earth with a lot of precipitation, because remember that the water vapor, increasing amounts of water vapor going into the air are going to come down in very strong storms or floods in different parts, which will lead to a lot of loss of life and livelihood and so on. So two scenarios, the choice is in our hands. What can we do? What can we do to try and limit the impacts of climate change? The first step is to understand the problem well, understand the scientific basis of the problem. And here we have tried to do today just that. We have tried to understand small pieces of the puzzle, like what happens to the ice when there is rise in temperature. How does rise in temperature, how does emission of CO2 lead to rise in temperature is something that we saw. Then what happens to snow and ice when there is a rise in temperature, be it albedo or sea level rise, is something that we saw. And how the increase in temperature is affecting the ocean by making it warmer, by making it more acidic, and so on. So this is trying to understand some scientific aspects of climate change, but climate change is a very complex issue which has a lot of other aspects as well. We should try our best to understand, but today we have understood the root cause of climate change, which is the greenhouse emissions. Increasing greenhouse emissions are the root cause of climate change, and at our level, what we can do is try and reduce our greenhouse emissions, which means our carbon footprint. And we can start small. There are very simple ways to start reducing your greenhouse emissions. The first step is to be conscious and to realize and try to audit where all we are contributing to greenhouse emissions and try to reduce them as much as possible. Conserving water, reducing waste, saving energy, or switching to more clean sources of energy like solar and so on, or renewable sources of energy, and reducing our dependence on fossil fuel based energy. Traveling by means and modes which are less emission producing. These are some of the things that we can do at our level, at our very small level, to reduce our greenhouse emissions and try and contribute to climate change amelioration. Of course, you can also do a little more than that, and when you grow up, especially our younger audience, when they grow up, should also be conscious citizens and try to make choices in our purchasing, in our elections, to move towards policies which are more friendly for the planet. So this is what we can do at the moment, and I hope that we have been able to create some awareness about this issue and try to understand a little bit more about how climate change works. Before we finish, most of these activities have been developed by the Office for Climate Education, the activities that you saw, and we have a link in the description box. And I want to give a big thank you to the team at the Science Activity Center at IISER Pune, Sarvesh and Tejal, Chaitanya, Mungi, Ankish, and of course Ashok, for helping me put this together and recording these activities for all of you. And you will also find the links to the description box in the description box to some of the videos that we used. And I'm happy to respond to some of the questions that we have received about climate change. Wonderful. We have received some questions which I will take, and some of these questions relate to the ozone layer. Now, this is a very interesting question, because ozone itself is a greenhouse gas that itself contributes to greenhouse effect, but that is not really the main gas that we need to worry about. In fact, what we were worried about is the depletion of the ozone layer. And now we have a few questions which are saying which are the gases that harm the ozone layer and how to save the ozone layer. So the greenhouse gases, other greenhouse gases, which are chlorofluorocarbons, which we actually saw in some of the very initial slides. The gases which are used in refrigerants, for example, are some gases that harm these fluorinated gases are gases which harm the ozone layer. However, I must clarify that though depletion of ozone layer is problematic, it is not really directly related to the climate change and the global warming that we are seeing today. Ozone is very important to keep the ultraviolet component of sunlight away from us and the harmful effects, to prevent the harmful effects of ultraviolet radiation reaching us. So yes, it is very important to reduce our fluorinated gases and protect the ozone layer, but it does not have a direct impact or a direct relation with the climate change and global warming that we are seeing today. Climate change is a natural process. How will we look at it? Yeah. So yes, it is, climate of the earth has been varying from glaciation to other effects and so on, but this effect has always been within a certain range. Is it a natural thing for the climate to keep changing? Yes, it is. But the difference here now in the climate change that we see now is that this change is not entirely natural. It is being caused by human activities, which is something which has not happened before. We are right now, that's why we are calling this age the Anthropocene. Human beings are having a big impact on a lot of things which are happening on the earth, and one of them is the climate. Another is, of course, an impact on the natural ecosystems and biodiversity and wildlife, which is also linked to climate change. But the concentrations of CO2, the normal variation in global temperature that we see in natural processes is being exceeded, is already crossed the limits in which it was fluctuating naturally. So it is a natural process, but we, within a certain range, but we are pushing it in one direction due to our activities, what effects that can have is not something that we have ever seen before. We are already starting to understand what impacts it can have, from floods to droughts to forest fires to loss of biodiversity and so on. And that is something which is why it is something that we must be careful about. There was another question which was related to wildlife and biodiversity, and yes, climate change is affecting wildlife and biodiversity in a big way. It is affecting biodiversity in various ways. One is that one of the major causes of greenhouse effect, in addition to burning of fossil fuels, is deforestation. Why? Because forests conserve or keep a lot of carbon dioxide sequestered. They in fact keep fixing the carbon dioxide, which is due to the process of photosynthesis. They fix the carbon dioxide from the atmosphere into their leaves, which means they remove carbon dioxide from the atmosphere and help with climate change. So deforestation, cutting down of forests in the Amazon, of course also in India, in different parts of the country, if there is less forests, which means that we are losing trees, and hence less and less carbon dioxide is going to get sequestered, or is going to get pulled out from the atmosphere. And also the carbon dioxide, which is already sequestered by these trees, is now going to get released again. So there is a dual effect of climate change on deforestation. And of course, when we have deforestation, you are destroying the habitats of all of the animals, right from the small little insects to huge animals like tigers or elephants. All of the biodiversity, all of the ecosystems living in those forests are going to get affected. The acidification of oceans and temperature increase in oceans affects marine ecosystems, from corals to whales. Everyone gets affected. So that is another impact on wildlife. When the temperature becomes warmer, species which were adapted to live in a certain region, in a certain zone, are no longer able to live there because it's getting too hot for them. So they start moving upwards, either upwards in terms of latitude to colder regions, or upwards in terms of height to higher patches in the mountain. And hence it changes in the entire balance of ecosystems, because species are no longer able to live in their niche, in their ecosystem. So this is another impact that we see on wildlife. And species are going extinct at an unprecedented rate, because of all these activities, because of climate change, because of deforestation, because of changing of land use. We are trying to use forest land for agriculture and industry and so on. So that was basically some of the main questions. If there are more questions, I'm happy to take them at some other point as well. You can reach me if you can go to the slide, further slides. You can reach me at my email address, which is given here. And thank you so much for joining us today. I hope this was not too scary. We do need to be aware, but there are things that we can do, and there are steps we can take to reduce and minimize the impact of climate change. Thank you very much.